Hi, welcome back to the continuation of Python code to solve systems of equations. So now that we are done writing the code, we need to be able to use it and see if we can solve the systems of equation. Remember earlier this had a list here in the previous video I did, but the proper way to do this is symbol. Okay, so if you had that list there, try to change it to symbol. Now, so we want to solve these systems. Okay, the first system, when we solve, we should have a unique solution pop up, and then the solution should give us should also pop up or should also follow. Okay, and likewise the next one, infinitely many solutions. So let's see, for the unique solution we have the system to be the one you have up there, x1 plus x2 and then the rest. Okay, so now let's go to running this code. When we run this, what happens? We have to enter the number of equations. So we have to enter, we have three equations, number of variables, we have three of them, that is x1 to x3. Right, the first equation is saying 1x1, right? So I'm particular about the coefficient of the variables. Okay, 1 times x2 plus 1 times x3 should be equal to 5. Okay, and now the next equation is 2 times x1 plus 4 times x2 plus 2 times x3 should be equal to what? 8. Okay. The next one is 1 times x1 plus 2 times x2 plus 2 times x3. This is equal to 8. Right, so we have these systems. Let's go ahead and compare to the system we actually have here. That's the exact system we have. These, everything is captured perfectly. So when it hits run, this should give us, I've solved that already, this should give us a system with a unique solution, right? So we should have the system has a unique solution pop up, and the solution will be printed, or we see the solution. Okay, so let me hit enter. Boom, we have our solution, right? We have the system has a unique solution, and then this is the solution. We have 2, -1, 4. That means we have x1 to be 2, x2 to be -1, and x3 to be 4. Perfect, right? Now let's run for a system where we'll have infinitely many solutions. How many solutions or how many equations do we have? 3. How many variables we have? 3. And the system with the infinitely many solution, I said, is this system, right? The second one, this one, right? Okay, so that system has infinitely many solution, and the system is given by 1 times x1 plus 1 times x2 plus 2 times x3 equals 2, and then we have the second equation to be 1 times x1 plus 2 times x2 plus 1 times x3 should be equal to 2. And we have 2 times x1 plus 1 times x2, plus 5 times x3 should be equal to 4. And so this is the system that we're about to solve. Let's see, there's a system here, all right, and with that system we're supposed to get an infinitely many solution. Okay, all right, so let's go to that. If I hit enter, we have the system has infinitely many solution, and this is the solution. We have x1 to be 2 minus 3x3, x2 to be equal to x3, and x3 is still x3. So x3 here is a free variable. You can choose anything to represent that, and that is your solution. So before you even start with a row reduce echelon form, you already have a solution to the system using this Python code. Okay, now let's go to the system that has no solution. And this is the system, right? We have the system to be this one. This is the system that has no solution. After inputting this in Python, we should have no solution pop up. Okay, so we have how many equations? We have 3. How many variables? We have 3. The first equation is 1 times, is the same thing as this, the first one that we wrote, but it's just one value that is changed here, plus 1 times x2 plus 2 times x3, or 2x3 like you are used to, And then I have the second equation to be 2 times x2 or x1, sorry. It's 1 times x1 rather, plus 2 times x2 plus 1 times x3 should be equal to 2. And I have 2 times x1 plus 1 times x2 plus 5 times x3 should be equal to 5. Okay, now if I click on this, or if I hit enter to run this, I should have no solution, right? The system has no solution. And I bet you just try to solve the system using your hand, and indeed you realize that the system has no solutions. Okay, so this is how you can write a Python code to solve the systems of equations that you've been solving so far. This is the code. If you did not see the code, this is how you go about it. From Sympy, you do this, you do that, go to the next one, and all of these have explanations. I've told you, all you need to know is how to use these. If you want, you can go ahead and read the documentation about Sympy and how it works, and then you'll be able to solve, or you'll be able to understand all these things that I have here. Okay, all right. In our next lesson, we'll start with eigenvalues, eigenfunctions, eigenvalues, eigenvectors. So stay tuned. See you next time.